Dear Professor Daston, Professor Strumza, Academy member, annual Buber lecture. During the course of the Jubilee year of the establishment of the Israel Academy of Sciences and Humanities, which happened 4 years ago, the division of the Humanities Division of the Academy has decided to establish a series of distinguished lectures named for the first president of the Academy, Professor Martin Buber. The annual Buber Memorial Lecture is the central feature of this division and annual program, and it is dedicated to humanities and social sciences. In view of Buber's broad range of interest and his activities on behalf of society and for the benefit of mankind, the Buber Memorial Lecture is meant to appeal to a broad audience of sciences, scholars, and knowledgeable laymen also. I am delighted to welcome you, Professor Lorraine Daston, and I am so pleased that you have agreed to present the 214th Buber Lecture. I would like to invite Professor Strumza now to introduce Professor Daston. Please, Guy.
Mrs. President, Professor Daston, dear colleagues, following Jürgen Habermas and Carlo Ginzburg, she will deal in her lecture today with some fundamental issues of humanistic scholarship. The Israel Academy is both honored and lucky that Lorraine Daston has accepted our invitation. I can think of very few scholars who are able to reflect on the various branches of the scholarly and scientific enterprise at once as daringly and as broadly as Lorraine Daston. In times in which scholars and scientists alike are required more ruthlessly than ever to make choices and to drastically narrow the focus of their investigation in the hope of reaching results and of making a career, Lorraine Daston has persistently refused to limit the scope of her interest and the breadth of the questions she asks. According to her own testimony, it is this inability to choose between the sciences and the humanities, to give up one for the other, that made her decide as a young woman to study the history of science. From her early focus on scientific aspects of the Enlightenment, she has, both alone and in interdisciplinary cooperation, showing by example where too many are content to preach, moved to explore different and sometimes curious aspects of Western modern rationality. Indeed, Lorraine Daston is an indefatigable explorer of the conditions, the limits, and the implicit presuppositions of scientific reasoning, and of its at times unexpected implications. Let me mention here, as a simple reminder of her amazing trajectory, some titles. Classical Probability in the Enlightenment, 1988. The Empire of Chance, 1989, with Gerd Gigerenzer and others. Wonders and the Order of Nature, 1150-1750. This is more than longue durée, this is real spagat. 1998 with Catherine Park. Objectivity, 2007 with Peter Gallison. Showing how the historian can contribute to public discourse, she recently participated in an attempt to understand, I quote, a title, How Reason Almost Lost Its Mind, The Strange Career of Cold War Rationality, 2013. I have mentioned here only some of the books she authored or co-authored, and none of those she edited or co-edited. Neither did I refer to her more than 130 articles. Since her doctoral studies at Harvard, her career and her life has brought her to teach in some of the best universities in the United States and in Germany, and to give distinguished lectures in many other places. She has been awarded important prizes on both sides of the Atlantic. It would probably be futile and certainly boring to try to list these places and these prizes, and it would be unfair. You came to hear her, not me. As we are at the Academy, however, and since I understand that her lecture today will deal with the work of academies, I should perhaps at least mention that she is a member of the Berlin-Brandenburg Academy of Sciences and Humanities and of the Leopoldina, a fellow of the American Academy of Arts and Sciences, as well as a corresponding member of the British Academy. Since 1995, Lorraine Daston has been director of the Max Planck Institute for the History of Science in Berlin, where she is also a permanent fellow of that marvelous institution that is the Wissenschaftskolleg. She also retains positions at Humboldt University and at the University of Chicago. Once upon a time, we thought that rationality was both perennial and universal, identical across ages and continents. One does not have to be a postmodernist relativist to acknowledge the existence of different types of rationality, and that rationality itself has a history, which Lorraine Daston has called Athena's biography. One can compare rationalities across civilizations, for instance, as Geoffrey Lloyd does between Greece and China, or across time in the Western world, as she does, developing a full-fledged historical epistemology. Let me conclude by referring to a very beautiful text of hers, her inaugural lecture at Humboldt University, a text which, to the best of my knowledge, has not appeared in English. In The Cognitive Passions, Astonishment and Curiosity in Early Modern Europe, she argues that emotions are intimately linked to the acquisition of knowledge, and that early modernity saw the inversion of long-ingrained attitudes to astonishment and curiosity in the process of cognition. While astonishment had been considered to be a positive emotion and curiosity, at least since the Church Fathers, a negative one, a dramatic transformation took place, completed around the mid-18th century, when curiositas had fully become respectable and identified as the motor of scientific research. A real genealogy of rationality thus emerges from the intertwined histories of emotions and sciences. I cannot enter here in the details of her tour de force, but hope to have given you at least a glimpse of what she does with much passion and great success. Intellectual history at its best, with direct, immediate implications for all fields of scholarly and scientific investigation. Thank you.
Madam President, members of the Academy, dear friends and colleagues, I must thank Guy Stroomsma for that introduction, which was as eloquent as it was gracious. Thank you very much. It is a great honor to deliver a lecture named for Martin Buber, the philosopher and first president of this Academy. It is a privilege to address the members of this Academy, and it's a great pleasure to see so many friends and colleagues here. Thank you very much, all of you. As Guy mentioned in his introduction, I'm going to talk about academies mostly in the 19th century, but I'm also going to talk about the relationships between the humanities and the sciences. We're at a position now where the relationships between the humanities and the sciences might be described as tense, if not outright hostile. I'm going to return us to a period where the humanities and the sciences, at least for some matters, made common cause. I do this not because I believe that history repeats itself. History never repeats itself. I do so because history can serve very usefully to unsettle some of our most taken-for-granted assumptions. So I begin. Once upon a time, but not that long ago, before there were two cultures, there was big science, or rather, to use the mid-20th century language of the two cultures, there was big science and there was big humanities. And the humanities were, in fact, in the vanguard. The Corpus Inscriptionum Latinarum, a collection of all known Latin inscriptions from antiquity, begun in 1854 by the Prussian Academy of Sciences, was the prototype of many subsequent grand undertakings, including the Carte du Ciel, the Great Sky Map, an astrophotographic mapping of the entire night sky, inaugurated at the Paris Observatory in 1887. These two projects, one in classical philology and the other in astronomy, were absolutely unprecedented in their grand scope, their huge budgets, and their labor organization on an international scale. They were emblematic of the rising prestige of both fields, both of classical philology and astronomy in the 19th century. The philologists were dazzling the public with the decipherment of ancient languages and the reconstruction of ancient texts and artifacts, and the astronomers with sensational discoveries of new planets and ever more precise predictions of comets and eclipses. The Corpus Inscriptionum Latinarum, the corpus of all Latin inscriptions, known as the CIL to all scholars of classical antiquity, and the Carte du Ciel, were also emblematic of how the humanities and the sciences during this period shared practices of compiling archives for future research. Before there were two cultures, made famous by C.P. Snow's Reed Lecture at the University of Cambridge in 1959, there was a common culture of what I'm going to call the sciences of the archives. So what are these sciences of the archive? Those human and natural sciences that depend on collections of data and objects in order to pursue research in the present and, at least as important, to ensure the possibility of research in the future. You can find examples in many disciplines. Think of the type specimens enshrined by botanists, or the core samples drilled by geologists, the ancient Babylonian observations which are still referred to by astronomers, the data banks now being assembled by geneticists, the weather diaries and ship's logs of past centuries being trawled by climate scientists, and of course the libraries and the archives visited by historians. These are the sorts of collections, and this is by no means an exhaustive list, of the sciences of the archives. In the early 21st century, the rage for big data, we have once again entered an archival epoch, both in the sciences and in the humanities. But we've been there before, and perhaps there are some lessons to be learned from the first age of the big sciences and the big humanities in the mid-19th century. In this lecture, I'm going to use the Corpus Inscriptionum Latinarum and the Carte du Ciel, the biggest of the big humanities and big science during the century that invented both, to argue two theses. First, the methods and aims of the sciences of the archives cut across the two-culture divide and in ways which are significant for us still today. And second, the big science and the big humanities of the 19th century reveal the darker side of scientific progress. What happens to eternal truths if each new advance overturns what we thought we knew? The 19th century was arguably the first century to realize this. Scientific progress is as old, at least, as the 17th century, but until about the 1820s and 30s, it was thought of as cumulative progress. New sciences would be conquered, the empire of science would be expanded, but there would be no revolutions. The word revolution comes into science at exactly the same time it comes into politics with the French Revolution, and quite ironically, the first person, the first scientist to use it for a scientific epoch-making discovery is Lavoisier, whom, as some of you know, was a victim of the French Revolution. By the 1820s, scientists are having to reconcile themselves to the fact that scientific progress is not just cumulative, it's also genuinely revolutionary. At latest by the 1820s, when Newton's corpuscular theory of light was overthrown by a crucial experiment showing the wave theory, the wave properties of light, at latest, scientists had to reconcile themselves to the fact that the price of scientific progress was scientific oblivion. So let me start with the first of these projects. It's Berlin, 1858. Theodor Mommsen, who's that very serious young man in the middle here of these three classical philologists, this is a photograph from 1848, is barely 40 years old, and he is addressing the Prussian Academy of Sciences on the newly approved project of the Corpus Inscriptionum Latinarum. You must imagine this is a guy who is barely a postdoc, and he is addressing one of the most distinguished bodies of scholars in the world, all his senior by many years and in achievements, with an air of serene self-confidence that he is going to be able to pull off the Herculean task of gathering all Latin inscriptions from the length and the breadth of what was once the Roman Empire, and he's going to do it in 4 years. He's not yet the monument that he's about to become. He's not the celebrated scholar and the statesman. He was a member of the first German Reichstag. This statue at the Humboldt Universität in Berlin bears tribute to that memorial Mommsen. In 1848, he's much more like this serious kid in the middle. Mommsen's audience of academicians must have entertained some skepticism about his promises. So, for example, think about the length and breadth of the Roman Empire. This is one of those inscriptions, just one of the hundreds of thousands of those inscriptions that survive, and it's in Spain. Going to Spain was no easy matter in 1858. Going to Northern Africa was positively dangerous. A comprehensive collection of ancient Latin inscriptions had already been tried and failed, not once, not twice, but 4 times, at least 4 times, starting in the early 17th century. The most recent project to founder of this kind had been begun in 1843 by the French. The first thing the French did, or almost the first thing the French did when they conquered Algeria in 1843, was to start a Corpus Inscriptionum Latinarum, because as they wrote, we are suited by both language and heritage to become the new Rome. This was a project that bit the dust in 1848 with the revolution of 1848. And then there was the Prussian Academy's own earlier inscription project, this time on Greek inscriptions, the Corpus Inscriptionum Graecarum, which had been begun in 1815 under the leadership of the philologist August Buber. The first volume appeared a decade later in 1828, and the second a dawdling 15 years later in 1843. No wonder the members of the historical philological class of the Berlin Academy were skeptical that this young whippersnapper was going to pull this off in a mere 4 years, especially since they knew that there were thousands more Latin inscriptions than there were Greek inscriptions. So why did Mommsen think that he could succeed where so many before him had failed? In one word, or rather two, critique and organization. Raised in the new philological religion of textual criticism, Mommsen believed that his new methods would detect false readings and forgeries propagated, whether wittingly or not, by his predecessors. And Mommsen wanted to take critique a step further. Whereas previous philologists had been content to travel to libraries, at least when it was convenient, to consult published sources and, in some cases, unpublished manuscripts, especially those, in the case of Latin inscriptions, held by the Vatican, although Mommsen despaired of a library that was only open for 90 days a year and then only for 3 hours a day. But Mommsen wanted something more. He insisted that it was necessary at some point to leave the library for the field to return to the original inscriptions themselves. And he practiced what he preached, whereas August Bock, the man who was in charge of the Corpus Inscriptionum Graecarum, had not even bothered to travel to Paris to check Greek inscriptions. And as far as Bock was concerned, modern Greece, which was then winning its independence from the Ottoman Empire, was almost as inaccessible as ancient Greece. Mommsen, however, in contrast, was up at 5:30 a.m. to inspect the antiquities in every off-the-beaten-track Italian village, clambering up ladders to transcribed weathered inscriptions on bridges and buildings. This is a sketch of Mommsen climbing up a ladder to decipher one of those Latin inscriptions. And sure enough, despite this added and very strenuous requirement of autopsia, Mommsen's team of young philologists began to turn out volume after volume of transcribed Latin inscriptions starting in 1863, producing 15 folio volumes by 1899 with the regularity of manufactured goods. And that simile to the factory is Mommsen's own. Although Mommsen did not make good his promise to complete the project in 4 years, the steady rate of publication and the discovery of ever more Latin inscriptions allayed the fears of stagnation that had mired Bock's earlier efforts. And some of you who are classicists will be familiar that the Corpus Inscriptionum Latinarum is still ongoing. Here's one of its more recent volumes. This was the context in which Mommsen invented big science, Großwissenschaft, both the word and the thing. He coined the term. Addressing the Prussian Academy of Sciences much later, by this time he is that memorial figure of the statue you saw in the courtyard of the Humboldt University, in 1890, his model of projects for academies had become the flagship of the Prussian Academy. He observed that science, and he's here using the German word Wissenschaft, so embracing both the humanities and the natural sciences. He says, Wissenschaft also has its social problem, as in the big city and big industry. Big science cannot be achieved by the lone individual, although it can be directed by one, a necessary element of our cultural development and one whose proper bearers are or should be the academies, end quote. Mommsen's vision for the academies was that they were going to be the trans-historical institution that would preserve the continuity of research over decades, over centuries. Individual scientists, individual scholars would come and go, but the academy would endure. The academy was, in Mommsen's view, something equivalent, perhaps, to the medieval church, an ideal community that would serve as the bearer and the repository for the archives to which he had devoted his lives. This was not the only big science project that Mommsen and the Prussian Academy launched. First, there was the Corpus Inscriptionum Latinarum, then there was the Thesaurus Linguae Latinae, then there was Byzantine numismatics, then there was the prosopography of late antiquity, the Aristotle lexicon, and on and on and on. The physical mathematical class of the Prussian Academy looked on with envy and increasing alarm as year after year their humanist colleagues cashiered the lion's share of the Academy's budgets. By 1900, Arthur Auwers, who was an astronomer and secretary of the physical mathematical class, and just to give you an idea, the physical mathematical class was by no means the historical philological classes junior in terms of the distinction of its members. This was a class that included the likes of Hermann von Helmholtz and Émile Dubois-Reymond and Rudolf Virchow. In any case, ours, by the 1890s, is prodding his colleagues in meeting after meeting to come up with research projects that could compete with the juggernauts already launched by the historical philological class. Ours insisted, in principle, the natural scientists also subscribed to the model of lavishly funded big projects, Großbetrieb der Wissenschaft, that had brought the Prussian Academy so much fame and fortune. And one has to understand that Mommsen was a genius, not only in commandeering the Academy's usual annual budget, but in persuading the king that even more money should be granted to these enormous big humanities projects. But in practice, ours admitted, the scientists had left such glittering undertakings entirely to the humanists. Ours wasn't the only astronomer to have taken note of the triumphant rise of big science in the humanities. We are now going to shift the scene from Berlin to Paris. It's April 1887, and the Paris Observatory awaits distinguished guests. The world's astronomical elite, who expected to be wined and dined in style. Here we see the members who attended the first meeting for the Carte du Ciel in 1887. And nor were the astronomers disappointed. 9-course banquets, evening concert, leavened the long days of deliberations on whether reflecting or refracting telescopes were best suited to astrophotography, how to divide up the labor of photographing the whole sky among 18 participating observatories, and the merits of making a star catalogue as well as a map of the heavens. The director of the observatory, Admiral Ernst Mouchet, and his subsequent directors, his successors, staged the Carte du Ciel with all the pomp and circumstance of a diplomatic congress, for which the observatory was decked out with gleaming crystal, Sèvres porcelain, phalanxes of Louis XIV armchairs upholstered in red velvet, and galaxies of silver candelabra. In the archives of the Observatory of Paris, you find these requisition notices, wanted, 120 silver candelabra from the national stores for the Carte du Ciel Congress, a small botanical garden worth of flowers requisitioned from the Jardin des Plantes. Whenever the French government balked at the mounting expenses of this project, the observatory director countered that the success of the project was a point of honor for France. And here you see a drawing of a subsequent Carte du Ciel meeting in 1891. The 58 astronomers from 16 countries plus 3 colonies who met in Paris planned what one contemporary called the greatest venture yet undertaken in astronomy, namely a complete photographic map of the sky, including all stars down to the 14th magnitude. And of course, photography has a double role here. First, it's enormously efficient because it can automatically capture a quadrant of the sky in the time that it would have taken perhaps to draw manually 1 or 2 stars. It could capture thousands. And moreover, by adjusting the exposure time of the film, it could capture stars down to a faintness of magnitude, down to the 14th magnitude, that would have been unimaginable even with the most powerful telescopes. Only the combined and prolonged efforts of almost a score of observatories in both the northern and southern hemispheres could produce what the promoters hailed as an imperishable monument, a photographic record of the authentic state of the universe visible from the Earth at the close of the 19th century. And the proportions of this project were indeed monumental. This is the telescope that made it possible. This is a refracting telescope at the Paris Observatory, which was outfitted with a camera. One of the most ticklish issues to be debated at that 1887 1887 Congress in Paris was whether or not refracting telescopes would be used for the enterprise or reflecting telescopes. And it's a sign of the willingness to compromise that even the British astronomers, who A, of course, were very proud of the reflecting telescope because this, of course, was the invention of Isaac Newton, and B, perhaps more substantively in this context, knew that at least in their hands, the reflecting telescope produced better astrophotographic results. Nonetheless, they sacrificed their favorite instrument to this refracting telescope in the name of uniformity. I'll return to this point in a moment. 18 observatories from Helsinki in Finland to Melbourne in Australia labored to amass charts projected in 1912, and that was in 1912, to stack 32 feet high and weigh about 4,000 pounds. So here you see the participating observatories with their assignments. And you'll notice that the assignments are not equal. So those few observatories in the Southern Hemisphere, the Cape of Good Hope, Sydney, Melbourne, Rio de Janeiro, eventually had to be replaced by another Australian observatory by Perth, had the lion's share of, just in terms of the degrees of the project. This will be significant for their future. Why did the astronomers want this snapshot of the sky circa 1900? Their hope was that because astronomical processes unfold on a superhuman timescale, too long to be perceptible within a short human lifetime, the appearance of new stars, nebulae, and comets, the telltale motion of as yet undiscovered planets, the incremental proper motions of the fixed stars, all of these would be revealed to the astronomers of the future by comparison with this snapshot of the sky as seen from the Earth circa 1900. And as the deliberations of that 1887 International Congress and subsequent meetings, 1889, 1891, 1896, 1900, 1909, it goes on until 1974, as these meetings make clear, the intricate coordination of telescopes, photographic plates, micrometric measurements, and myriad other details to ensure that the parts of the map would be commensurable required that participants relinquish control not only of their instruments and their methods, as the British astronomers had done in adapting the French refractor, but also over the choice of research area for years to come. Moreover, they relinquished their budgets. Here is an attempt, an early attempt, this is from the 1890s, to print the results of the star maps. This is one of those glass photographic plates. What you see here is an engraving. That is, somebody, an artist, manually engraved the photograph. This was a work of painstaking meticulousness with an enormous potential for error, and therefore proofreading was the devil's job, simply to produce one volume of what was envisioned as a 200-volume set of such heliogravures was going to cost 1,000,000 French francs, 1,000,000 French francs in 1890. You can imagine how the French minister, the Minister of Public Instruction, balked at these expenses, and also what it meant for those observatories with budgets somewhat smaller than the opulent budget of the Parisian astronomers. The Australian observatories, who were responsible for 18% of the sky, ended up missing all of 20th century astrophysics because of their commitment to the Carte du Ciel. That is, when other observatories, Harvard, for example, or Denmark, both observatories that had refused to take part in the Carte du Ciel, when other observatories were pioneering spectroscopy, figuring out what stars were made of, the poor Australian observatories and also the provincial French observatories were, at least they felt, morally and contractually bound to continue their commitment to the Carte du Ciel. This was not simply a paper agreement. And it must be said that in terms of experiments in global governance to date, this is one of the most successful. Let's step back now from these two projects, the Corpus Inscriptionum Latinarum in classical philology and the Carte du Ciel in astronomy. What have we got? 2 million stars, 180,000 Latin inscriptions, tons of glass photographic plates, thousands of paper squeezings taken from ancient stones of bronzes, 254 volumes of published astronomical data, 17 volumes of Latin inscriptions with 13 supplementary volumes containing figures and indices. What these projects of big science and big humanities produced were not discoveries, but the archives from which future discoveries were supposed to come. Here you see by date here, the number of publications which cite the Carte du Ciel, and notice that there's a peak around 1990, which I'll come back to in a moment. But note that in the early years, the yield is really quite low and then sinks to, not only during the war, during 1940, but really throughout the 1950s and 60s to a very, very low point and then springs up again. That was, in some ways, implicit from the very beginning in these projects, that there's going to be an ebb and a flow of their fruitfulness. When we look at the concrete practices that are involved in these two projects, and when I say practices, I mean what scholars and scientists actually do on a day-to-day basis, as opposed to what they say they do in their prefaces, and how they invest their always all too scarce resources, not only their financial resources, but their instruments and their human resources, that is how they vote with their feet. Gaping holes start to emerge in the wall that separates the two, allegedly two cultures of the humanities and the sciences. The main contours of our current disciplinary map were drawn in Germany in the later half of the 19th century. It was then that the, at that time, mighty German universities and academies mapped out the grand divisions between the humanities and the sciences. They actually coined the terms Geistes and Naturwissenschaften. It's the first time it's not only that they're first articulated during this period, they're institutionalized and justified. We have the familiar opposition of the bookish humanities, guardians of memory in the library, and the hands-on sciences, discoverer of timeless truths in the laboratory and the observatory. These have their roots in these second half of the 19th century classifications of the sciences, which can be found ad nauseum in the Rektoratsreden of Wilhelm Dilthey, Hermann von Helmholtz, and Wilhelm Windelband, amongst others. But at about the same time that Helmholtz and Dilthey were drawing bold lines between the sciences of memory in libraries and the sciences of natural laws in laboratories and observatories, the most advanced scientific research institutions in Europe and in North America were not only purchasing state-of-the-art instruments and building new temples to science, they were locating libraries at the heart of observatories and laboratories and busily stocking them. I'll just give you one example. This is the blueprint for a deluxe physiological institute built in Berlin for the superstar physiologist Émile Dubois-Reymond. Room number 17. Does this one work? No, this one doesn't. Okay, try this. Here's room number 17. This is the laboratory, and it is the largest building. It's the largest room in the building. But here, the second largest is the library. Here, number 7. And it's the library which is right next to the director's office. Or another example in this case, somewhat more anecdotal. This is the celebrated naturalist Alexander von Humboldt in his study. Alexander von Humboldt, as many of you will know, was famous for his precision measurements of everything from the height of the Andes to the paths of ocean currents. And he's in his endearingly messy library, and you note that his scientific instruments, like his telescope here in the back room, and here on the desk also there are magnetic instruments here, are interspersed amongst his books. His books and his instruments both belong to the same sorts of practices. The libraries represented past discoveries, both for the humanists and the scientists, and the archives represented the possibility of future discoveries, again, for both the scientists and the humanists. Libraries and archives are the expression, the material expression, of the practices of collecting, collating, and conserving large troves of data, whether in the forms of manuscripts, books, specimens, or databases. For some of the sciences, such as astronomy or geology or demography or meteorology, the superhuman timescale of the phenomena under investigation and the extreme difficulty of detecting subtle correlations dictate the careful preservation and consultation of past observation, from ancient Babylonian star catalogs to medieval weather diaries to parish church records of births and deaths. Without the treasures stored up in libraries and archives, there would be no way to discern long-term trends in either climate or human mortality. Many other sciences depend on records because there's just simply too much for any one person to know. Whatever the rhetoric of first-hand observation, the reality is that since the 16th century, the modern empirical sciences have always and essentially depended on testimony and record keeping. Because nature is vast and labyrinthine, empiricism in the natural sciences is hugely labor-intensive and therefore collective. And the same holds mutatis mutandis for some of the humanities. The precondition for a stable intellectual tradition is a stable collective memory. And at latest by the 16th century, humanists were complaining there was too much for any one scholar, no matter how learned, to know alone. If anything, the rise of the database and the internet has intensified the links between the practices of those branches of the sciences and the humanities that depend crucially on large compendia. These data-hungry disciplines often share the very same computer programs that structure databases and the very same visualization techniques used to make sense of them. I'll just give a few examples. Whether it's a classicist who is trawling the Greek and Latin corpus, 9,123,283 words at last count in the Perseus Digital Library. Here's the homepage for the Perseus Digital Library, for all uses of a certain word, or it's a geologist who's searching for all known fossils of a certain extinct species, 1,054,916 taxonomic occurrences to date in the paleobiology database. Both user interface and search engines are remarkably similar. Moreover, there's a striking continuity between the collecting practices of the great 19th century museums and the atlases and other compendia published on the basis of these collections and the dernier cri digital techniques of microbiologists, geneticists, and paleontologists. Despite the hype surrounding all things digital and the undeniably greater capacity, flexibility, and speed of computerized databases, the practices of collecting, inventorying, describing, image making, collating, and publishing have remained surprisingly stable since the monumental projects of the 19th century. Like the Corpus Inscriptionum Latinarum of the philologists, the Carte du Ciel of the astronomers, or for that matter, the vast botanical collections of Kew Garden in Imperial Britain, the fossils amassed by the Paris Muséum d'Histoire Naturelle, or the Monumenta Gammae Historica of the medievalist. These are all examples of 19th century archival projects. These undertakings are vast in scope, collective in authorship, and long, very long in the making. Their media are as different as the multi-volume edition. This is a small subset of another one of those great 19th century archival projects, the Patrologia Latina, which ran in its entirety to 217 volumes. So they can be books on a shelf, but they can also be glass photographic plates. These are the glass photographic plates from the Carte du Ciel, which are still carefully preserved at the participating observatories. Or they could be drawers of fossil specimens, as these fossil specimens excavated around 1891 from the Burgess Shale. Digitalization is only the last in this parade of ways to make data visible, accessible, and durable. Data-driven science is the new name for those disciplines that amass and organize heaps of information on everything from biodiversity to climate change. But the practices involved are neither new nor the exclusive province of the natural sciences. On the contrary, as we've seen in the case of the Corpus Inscriptionum Latinarum, the big humanities of the 19th century paved the way. Why were these archival projects funded to the degree that they were in the 19th century? And not just funded. In some ways, money represents the least of the sacrifices involved in these projects. The human costs were almost as great. The young philologists who were enlisted by Theodor Mommsen for the Corpus Inscriptionum Latinarum, the astronomers who dedicated their lives to the Carte du Ciel, were very consciously giving up much more glamorous careers in which they might have dazzled as individual scholars. Why? Why invest in these kinds of distinctly unglamorous archival projects? The proponents of the Corpus Inscriptionum Latinarum and the Carte du Ciel described their projects as monuments. These were supposed to be the modern age's answer to the pyramids of antiquity and medieval cathedrals. But the form these 19th century monuments took was not architectural, but archival. And it's worth, I think, reflecting for a moment on what kind of culture decides that its most lasting legacy to subsequent generations is not going to be a temple, a church, or some other monument in brick or mortar, marble, glass, concrete, but rather an archive, invisible and even when visible, unprepossessing. They invested in these projects out of the conviction that it would enable their successors to conduct research for centuries, if not millennia to come. And I say millennia advisedly. The architects of the Carte du Ciel hoped to hand down their astrophotographic map, quote, to the astronomers of the year 3000 at least. And that last qualification, the at least, is not in deference to the rise and fall of civilizations, much less to the extinction of astronomers. It's rather to the worry that perhaps the chemical deposited on the photographic plates would not remain eternally inalterable. At least in the imagination of their founders, the archives are forever. In contrast, the results of science and scholarship are all too ephemeral. At least that seemed to be the moral drawn from the accelerating pace of progress in both classical philology and astronomy by the mid-19th century. Already, again, the humanities are in the van, already by the 1820s, the classical philologists had begun to worry about being surpassed, and still worse, forgotten by their own students. as new discoveries and critical methods overflowed the pages of the new journals established to publish them at a faster clip than traditional book presses could keep up with. A few decades later, their colleagues in the natural sciences also began to feel time's hot breath on their necks. By 1844, Alexander von Humboldt, by 1844 very aged indeed, reflected sadly on the fact that, quote, all that is connected with empirical research and with fathoming of phenomena and physical law takes on a new aspect every few decades, so that, as one commonly says, outdated scientific writings fall into oblivion as no longer readable. By 1900, the tempo of scientific advance had quickened to the point that the French applied mathematician and physicist Henri Poincaré could write, as he put the final touches on his textbook of electromagnetic theory, that between the time that he delivered this book to the publisher and it appeared in the bookstores, something else would have changed to falsify his book. He wrote elegiacally about how ephemeral scientific theories had become, calling them ruins piled upon ruins. This is the background against which the tremendous disciplinary exertions of the 19th century sciences of the archive on behalf of the future become comprehensible. The scale of cost and commitment demanded by the Corpus Inscriptionum Latinarum and the Carte du Ciel were unprecedented. Projects conceived on the scale of a decade extended to a century or more. Budgets were endlessly revised, always upwards. Careers dedicated to undertakings that outlasted individual lifetimes and subordinated individual ambitions to the needs of the disciplinary collective, and not the actual disciplinary collective of one's here and now colleagues, but the astronomers of the year 3000, the philologists of the year 2525. The investments in time, talent, and money were enormous. The sacrifices, especially for the astronomers, were even greater. The finest young philologists were sent out to transcribe inscriptions in regions where they faced danger and even death. One of Mommsen's younger colleagues, the young Danish philologist Olaf Kellerman, for example, died of cholera in Rome transcribing Latin inscriptions. Another few were lost in northern Africa looking for Latin inscriptions. Observatories pledged to the Carte du Ciel tied up resources that could have been used for new instruments and research initiatives for decades to come. I've already mentioned the case of the Australian observatories, which simply missed the 20th century in astrophysics. 19th century projects, like the Corpus Inscriptionum Latinarum and the Carte du Ciel, stamped the model of the most prestigious, the most expensive, and longue durée science ever since, and I do mean long. So the Carte du Ciel was peremptorily ended, not completed, ended by the International Astronomical Union in 1974, almost a century after it's begun. And the Corpus Inscriptionum Latinarum is still ongoing. Think about this for a moment. Prussia is no longer with us. We have had 2 world wars. Germany has been divided and reunified. The Prussian Academy of Science became the Akademie der Wissenschaften of the German Democratic Republic. It is now the Berlin-Brandenburg Academy of Sciences. The Corpus Inscriptionum Latinarum goes on. To create and curate an archive is to assume disciplinary continuity, sometimes across centuries, sometimes even across millennia. There's always a utopian element in the sciences of the archives. It's a vision of a community that will endure and cherish the collections so carefully laid up as provisions for future research. Yet in the mid-19th century, when the sciences of the archive invented big science and big humanities, the rosy vision of science stretching into the far future was shadowed by fear. This was not the fear that science might fail or disappear, but rather that they might succeed too well. By 1850, scientific progress had accelerated to a dizzying tempo. Today's established truths could so quickly become tomorrow's errors. This was a problem, especially for those scientists who were trying to get the newest results in physiology, chemistry, and physics into the textbooks of the schools. Because, as the teachers retorted, how can we teach something which is truth today but lies tomorrow? A problem we have not yet solved. Scientific revolutions occurred even more frequently than political ones. Sooner or later, every scientific doctrine would give way to another. The initiators of the first big science and big humanities were haunted by the specter of their own obsolescence. They were already looking over their shoulders, afraid of being overtaken by their students. Better to invest in building firm foundations for future science than in the flimsy structures of the present. Only the archives endured, a legacy of present science to its posterity. And that's the paradox of the first wave of big science. Never before had the natural and human sciences advanced at such a breakneck speed. Never before had humanists and scientists dared to conceive of such gigantic projects spanning continents and generations, and never before had governments invested so heavily in the sciences. Never before had the sciences been so prestigious as proofs of cultural superiority. Yet the price of all of this glittering success was gnawing uncertainty. Would anything of the scientific present be salvaged for the scientific future? Or would it all be forgotten, like the science of past centuries, or indeed past decades? What present science could secure was no longer eternal truths, but eternal archives. One might call this the pathos of positivism. We're used to thinking of positivism in its swaggering mood, arrogantly allocating to itself the projects and resources of progressive science. But there is a shadow side, or a second wave of positivism, which was the positivism that was acutely conscious that all that would endure, if it endured, would be facts. And that is the shadow side of positivism that made possible the sciences of the archives. So it's time to conclude. At the outset of this lecture, I set out two theses. One about how we might rethink the classifications of knowledge, and the other about the more melancholy side of scientific advances and scholarship. Let me review both of these theses and think a little bit about the implications of the first wave of big humanities and big science for where we are now in the early 21st century. So first, classifications of knowledge. Most current ways of dividing up systematic knowledge are based on subject matter. The sciences study the natural realm, the humanities and the newcomers, the social sciences, study the human realm. These divisions are mirrored in the physical organizations of buildings on modern university campuses. I'll just give you one. This is the main quad at Stanford, and it's hard for you to see, but I can point out to you. So here is the main quad, and it has four corners. There is the history corner, the language corner, the geology corner, and the math corner. And we are not surprised to see that the geology corner here and the math corner are very close to the physics building where the laboratories are and the engineering sector, nor are we particularly surprised to see that the history corner and the language corner abut upon the library and the art gallery. This is simply an architectural testimony to what most of us take for granted, namely that mathematics is close to physics, and physics and astrophysics occupy the same building, and the music center is very far from all of them. If this were a medieval university, and if medieval universities had had campuses, astronomy, mathematics, and music would all have been clustered together. They are the disciplines of the quadrivium, while physics would have been elsewhere. It would have been housed with philosophy, the study of universal causes. History, biology, and geology would all have shared quarters because they're all concerned with particulars, historia, as in history, but also in natural history. As I said, nowadays, we're not surprised that history and language are close to the library. Rendered in brick and mortar or in mock Gothic, or in the case of Stanford, mock Spanish revival, these are the classifications of knowledge that guide our steps and our assumptions about what knowledge is. This is the map of the great continents of knowledge and the oceans that divide them. I've argued that we could draw this map differently if we paid more attention to the practices of science and scholarship rather than to the subject matter. More specifically, what I've called the sciences of the archive straddle the sciences-humanities divide. Whether that archive is a repository of books or a database, the practices that it fosters are remarkably long-lived and widespread. From the 18th century botanical herbarium to the 19th century Corpus Inscriptionum Latinarum to the 20th century search nucleotide database, from botany to classical philology to genetics, very similar practices of collection, compilation, and collation tunnel straight through the wall that allegedly divides the humanities from the sciences. This is not an argument for erasing all distinctions. The practices that I'm talking about by no means exhaust all of the practices of either the humanities or the sciences. Interpretation, experimentation, modeling, commentary, measurement, translation, graphing, computer simulation, statistical inference. The list of learned practices is long and diverse, and not all of them are common to both the humanities and the sciences. Indeed, and this is perhaps the most important point, very few, if any, are common to all of the humanities or to all of the sciences. Moreover, in both the humanities and the sciences, there are disciplines and subdisciplines in which the practices play only a minor role. For example, philosophy or theoretical physics. Nor do the practices of the sciences of the archive define what it is to be a science for anyone except the most ardent positivists. The gigantic efforts and expense required to assemble these compendia, whether they're of fixed stars or genomes, are never justified as ends in themselves. They are always, at least advertised, as the means to broader, deeper research. Hence, all of these metaphors of granaries, warehouses, sources, and in our finance-obsessed age, banks. They are the provisions upon which one draws and the foundations upon which one builds. They are the alpha, not the omega, of research. And this brings me to the second thesis. When do the sciences and the humanities channel their energies into these monumental archival projects? Or to repose the question in other terms, when does the promise of future research outweigh the attractions of present inquiry? At least in the case of the 19th century sciences of the archives, I've argued that the answer lies in the bittersweet realization that knowledge that progressed was knowledge that would not, could not, should not last forever, or even for the span of a single scientific career. At the moment when the prestige of classical philology and astronomy was arguably at its height, as witnessed by the willingness of governments to invest princely sums in archaeological excavations, mammoth telescopes, and other undertakings, both disciplines turned their attention from the discoveries of the present to the archives of the future. These were monuments that would transcend the labors and lifetime of any one individual and a legacy for future generations, or so it was devoutly hoped. I use the word devoutly here advisedly. The Vatican Observatory was probably the only institution to mobilize nuns for the task of measuring the plates of the Carte du Ciel. But the displaced language of religious commitment, of selfless and unstinting labor in the service of the hereafter, was absolutely ubiquitous amongst the project's moving spirits. Conjuring up those images of pyramids, cathedrals, and other architectural grandiosities that enlisted armies of anonymous dedicated laborers, late 19th century proponents of the sciences of the archives wanted monuments that would endure after time had erased all other traces of civilization. And despite the positivist bombast that surrounded these gigantic projects to compile thousands of Latin inscriptions, millions of star positions, melancholy lurked at their heart. I remind you of Poincaré's image of ruins heaped upon ruins. We're once again in the midst of an efflorescence of the sciences of the archives, now known as big data or the digital humanities. Once again, ambitious, expensive projects for the digitalization of all manner of corpora and for data mining of all manner of sources are on the agenda. Once again, utopian hopes are invested in the institution that will ensure the survival of these archives. For Mommsen, it was the academy. For us, it's the internet. Once again, the promises made for these projects are in the future tense. Only after we have digitized, so one reads in grant proposal after grant proposal, will we be able to theorize. There is no more reason to doubt these promises than those of the Corpus Inscriptionum Latinarum. This is a tool which is still in daily use by students of all aspects of the ancient Roman world. Or the Carte du Ciel. I remind you of that peak around 1990. The Carte du Ciel furnished some of the evidence for the existence of dark matter. But perhaps once again, there is reason to ask what nagging uneasiness has shifted our collective gaze from science present to science future, from what we think we know now to what we hope we, or rather our successors, will know in the future. Thank you very much for your attention. Shall I take questions? Thank you very much.
Any questions?
I'd love to, if people have questions. Yes, please. Yes.
Just a brilliant presentation, very brilliantly created. I'm sorry, I've got three. I'm going to just ask really quickly. One, I mean, you've raised the question of, the tension today, but why wasn't there more tension then, given the fixed, finite resources? One. Mm-hmm. Second, did you look at anything at all in terms of the standardization of the quality of the collection across countries? How were they able to standardize that? And the third, I'm sorry, but it was a brilliant presentation. And the third is, I mean, you kind of come very close to talking about this, but the concept of the knowledge being property. We're obsessed today on intellectual property, and yet it seems there that they saw it as a public good.
Mm-hmm. All three very good questions. The first, where did they get the money for this? They did it through a combination of shaming and sunk costs. So the shaming part came from, so what the Olympics are to perhaps our era, these projects were in the 19th century. When governments like France and Germany were not actually at war with one another, they were often at war with one another, but when they were not at war, they were competing as to who could have the biggest archaeological excavation. So France launched the Delphi excavation. It took only 3 or 4 years before Prussia countered with the Olympia excavation. These projects were high prestige elements in a national game of diplomacy. France in particular, as its influence waned vis-a-vis the British Empire, began to use all of its resources to make France a diplomatic and cultural capital. So you see international Congress after international Congress being bankrolled by the French government to get people to come to Paris and to identify Paris as the center of the civilized world, even if Britain was the center of the military and commercial world. So that's the first answer. But of course, you have to believe that the prestige of classical philology and astronomy is greater than the prestige of sports. for example. That was the case, believe it or not. The second question concerns coordination. That's why I said that this is, as far as I'm concerned, the most successful experiment to date in global governance. The minutes in the archives of the, especially the deliberations of the Carte du Ciel with those 18 participating observatories, at any moment they are about to split apart. The Oxford, for example, the Oxford astronomers could not believe the slowness of the Paris astronomers and threatened to secede. The Australian observatories kept asking for help from the northern observatories, which never came, of course. How did they ensure this kind of coordination? Through the means that diplomats have used for centuries. The amount of wine that was poured out. I found the menus of the banquets. And a kind of, I can't think of the English word for this, Männerfreundschaft. The toasts that are preserved go on for hours and hours and hours, which is the way, of course, in which diplomats have always attempted to anchor treaties. But these proved to be more lasting than almost any treaty made in the 19th and 20th century. I'm sorry, I've forgotten the third question. Property, yeah. That is perhaps the most utopian element of all of this. At no point, Mommsen could be quite chauvinistic at times, and rather morosely so. At one point, during one of these endless projects, I can't remember, it was the Thesaurus Linguae Latinae or the Aristotle Lexicon, where he'd hoped for help from the Italian scholars, and the Italian scholars, of course, had not delivered. He said, we are always alone. We Germans were always alone. We're going to have to do this all by ourselves. But at no point, even though he has this rather Eeyorish attitude about shouldering an unfair share of the burden, at no point was there a question but that this data would be available to all scholars everywhere, and similarly for the Carte du Ciel. There was never a question.
Really, thank you ever so much. Thank you ever so much for that wonderful lecture. What I'd like to push you on a little is that series of never before statements that you made towards the end. On that scale, never before, but I think there is an earlier phase. There's a history to the story that you tell. At least one moment I can talk about is in England, a sort of Baconian awakening of people like John Herschel, George Peacock, William Whewell, each of whom undertook massive undertakings. John Herschel's mapping of the southern hemisphere, Peacock's natural history of all methods of counting and calculating in order to yield, it's an enormous, it failed, but in order to yield a sort of generalized arithmetic, which he hoped would be a better algebra, and it didn't work out. But the undertaking was enormous. Whewell's tidology, which was a collaborative, as you well know, global, I mean, he used the entire British Navy and more. And then his history, his comprehensive history of the inductive sciences from the Greek to the present time, which is future-directed, if anything was. Now, it's a sort of baby phase in the story you tell, and most of these projects are single-handed, and yet they're utopian, and against the backdrop of the British Association, much wine and good food at least once a year in these banquets, and it's this context which is a sort of microcosm of what the story you tell, which I think is a stage in the genealogy of the moment you describe so well.
I think that's absolutely true, and it's most evident in the case of Herschel, the mapping of the stars at the Cape of Good Hope, because Herschel's successor, David Gill, is, along with Mouchet, the moving spirit behind the Carte du Ciel, and he's absolutely building on Herschel's accomplishment and Herschel's vision. I think the only difference here is really twofold, and one, you've put your finger on it, which is someone like Whewell, who I can't remember the bon mot about master of Trinity and omniscient, omniscient. Someone like Whewell, even Whewell wouldn't undertake a tidology all by himself. But these are at least small-scale operations, and they don't have the kind of either international involvement, international bankrolling, and above all, the vision of longue durée, the vision that many lifetimes are going to be needed to complete this project. I described it in reply to the previous question as the most successful experiment in global governance to date, but one might also think of it in terms of, I grope for analogies, an attempt to found something like the continuity of monastic orders. A community which is very religious in its language and overtones of commitments.
One more question.
I'd like to pick up this theme of religion, church, sacrality, the archive, collective memory, those kinds of longue durée themes that run through your excellent analysis of a particular type of archival activity, which is Enlightenment-rooted largely. Now, my point is this. How would you position Mayan temples, Native American totem poles, monastic libraries, and so forth, within the human archival project to preserve identity, to transmit memory, and to preserve a space in the longue durée of all peoples? Would it be fair to say that you are taking a particular case of a much larger human enterprise?
My work is done for me in that positioning was done by my historical actors themselves. When they reached for analogies for their projects, those were precisely the kinds of, the Library of Alexandria, not the Mayan temples, but certainly the Egyptian pyramids. And the novelty in this is to transpose that impulse and that language, from monuments which are still amongst the wonders of the world to the very unprepossessing drawerfuls of glass photographic plates of stars, or I don't know if you knew what this actually was at the outset of my lecture. Let's get back to it. You know, this object here in the background, this is a paper squeezing made of an inscription. And the reason the paper squeezing is made is that should weather or war or simply construction destroy the stone inscription, there will be somewhere in the dusty back rooms of the Berlin Academy a paper squeezing of the transcription. These are not objects that command the wonder of subsequent generations, but they're invested with the same sacrality.
Thank you.
Thank you so much. I saw that there are some more that want to ask questions, but maybe afterwards it's rather late. But there are two things now that I would like to do. First of all, I would like to thank you for a wonderful lecture. And first of all, give you this Martin Buber medal as an appreciation for your lecture. And you are also getting a scroll. I'll first read the scroll both in Hebrew and in English, and then I'll give it to you. ההרצאה השנתית על שם מרטין בובר. האקדמיה הלאומית הישראלית למדעים מתכבדת להעניק תעודת הוקרה זו לפרופסור לוריין דסטון, שנשא את ההרצאה השנתית לשנת תשע"ה על שם מרטין בובר, הנשיא הראשון של האקדמיה הלאומית הישראלית למדעים. חתומים רות ארנון נשיאה ויוסף קפלן, יושב ראש החטיבה למדעי הרוח. Martin Buber Memorial Lecture. The Israel Academy of Sciences and Humanities hereby expresses its appreciation to Professor Lorraine Daston for her presentation of the 2014 lecture in memory of Martin Buber, the first president of the Israel Academy of Sciences and Humanities. And signed, Ruth Arnon, president, and Yosef Kaplan, chairperson of the Humanities Division. And this is the scroll. Thank you very much. Thank you again so much for a wonderful lecture, and you can have this, plus this notice about this. To remember us by.
Very much.
Thank you. Thank you. This is very much appreciated.